Yes, good afternoon, students. Am I audible?
Yes, sir.
Okay. So, yesterday we were discussing the programs, example programs on strings. We'll complete that and we'll start with the introduction to data structures. So, I think we had finished till program number 7. Yeah, displaying the uh, string after the last occurrence of the character. So this was the thing what we understood. Since I've taken here as character star value, correct, no, the pointer. Now what it will do, this is going to return the last occurrence of the character. Say I'm looking for this a, it returns the last occurrence. The last a is occurring here, and so since I'm assigning it to a pointer, correct, no, what gets assigned is the address of this particular character, and then I'm displaying here. From here, so everything will be displayed. So, and I executed this also. Now let me run this and then we'll go to the next one. So you can just observe here. So string after last a is this. From there everything is getting displayed, and string after last u is everything is getting displayed. So in case if you want only the position of the last occurrence, so then you may take it as an integer variable. Okay, instead of character star value, I can, if I take it as int value and value is equal to this, if I do, what this will assign as the position, okay, of the last occurrence of that particular character. So we'll modify this and we will quickly see that. Now instead of this character star val, I'll take it as int val now. Now here string after, instead of this string after last, I can say the string the last occurrence, or let me do save as and take it as a different program. String after last character. Okay, I'll, because I don't want to modify this, let it be as it is. I'll save it as a different program. I'll save this, save as, so strings. Okay, I'll take it as, I think, 11th program, 11.c. let me make it. Okay, so 11.c. here what I'll do, this one I'll remove, I'll make it as int val. And then here I'll change this. Last character, last occurrence of character percentage %c is at percentage %d. This I have to change it to percentage %d, because now I have made it as integer. Return value I'm assigning it to integer. Okay, so this is the ch is the character percentage %t and at so and so position. I'll just say this. Okay, now similarly for the second one, last occurrence of char is percentage D, okay, and return 0. I'll save this. Let me include conio.h. stdio.h is repeated twice. Conio.h, and let me do clear screen here. Save. I'm compiling. So it's saying to okay, it's okay, no problem. Let me run and see. Okay, Alt F5. Okay, sorry, what it is written, last occurrence of character A is at position -17, and this is one second. Let me, so I think I need to cast it to integer. Yeah, now warnings are not there. I've casted it to integer. Let me check whether I'm getting the proper output. So output is not proper. Okay, let me say star. Okay, now we'll see. Again the same. Okay, now sorry, this is not returning the position. Actually it is returning the pointer address where the last one, the last occurrence of the character is starting. Sorry, I got confused. So what this always returns is the address of the last occurrence. Okay, now I cannot take it as integer. I got to make it a star, character star value itself. So value. So and now it's not necessary for you to cast it, because this always returns the address of the character. Okay, so you cannot do it that way. So now this cannot be percentage D now, so it has to be percentage yes only. And then percentage yes here. Okay, so now it is displaying. So it will display everything after that position. Okay, so now we'll go to the next one. So 8th program, so strings. Okay, so 8th program is this. So here string compare example we are saying. I have taken two strings here. One is left string GFG and right string GFG again. So I am comparing here using the built-in function int res is equal to string compare left string and right string. Now what strcmp returns, if both the strings are same, it will return 0. Okay, now this is same, luckily GFG and GFG. So the left string and right string both are same. So what this should return now is 0, and if 0, okay, I say strings are equal, otherwise I say strings are unequal, okay. And so we are also printing the value that is written by the string compare also, okay. So now since the strings are equal, it should print out the value 0, okay. Now let me run this. Okay. So you can see the strings are equal because clear screen was not there, and you can see the result of the previous execution also. Strings are equal and the value returned by strcmp is 0, okay. Now what I'll do, I'll change this to h. So I am just trying to compare now. I'll save this, Control F9, Alt F5. So now it is returning 1. Strings are unequal and the value returned by strcmp is 1. Now why it is returning 1? See, now what I am comparing HFG with GFG. So what is the sequence? So when I am writing, G comes first and later H. So something like this, G, H, okay. So the first string is bigger than what? The second string, something like that right now. See, first string I have H. In the second string I have the first character as G. Now this H appears in the alphabetical order, H appears after G, correct, no? So that is you are trying to do the subtract operation. So from HFG you are trying to subtract GFG. Now when I do, since this the ASCII value of H is 1 more than G, you will get the difference as what? 1. Say for example ASCII value of H is I am not writing the exact figure, I'll write something 56, okay. So but strictly speaking 56 is not the ASCII value of H, so I'll write it as 67, okay. And what is the ASCII value of G? ASCII value of G is 66, 1 less than that. So 67 minus 66 is how much? 1, okay. So that is the difference what you are getting. Now if both are G and G, say this is also G and this is also G, 66 minus 66, what is the value you get? 0, okay. Now you are getting the result as 1, okay. So that is the reason you got result as 1. So compare always returns the difference. OP people understood? Now let me interchange this. I'll make this as G, this as G, and this as H. Now what it should return you? Now what compare should return? strcmp. Am I audible?
Unequal.
Hello, am I audible?
Yes sir, you're audible.
Yeah, strings are unequal again, but what strcmp will return? Now I have interchanged. Earlier in left string I had H and in right string I had G. Now I have interchanged it. G and H I have made. Now what strcmp should return? Now what is the ASCII value of G? Say 66. Assume it is 66. What is the ASCII value of H? If assume ASCII value of G is 66, what should be the ASCII value of H? 67. 1 more than that. Correct, right? Now 66 minus 67. How much you should get? Minus 1. Okay. So what strcmp returns now is minus 1. OP people are following?
Yes sir.
Yeah, I'll save this. Now I'm compiling. Okay, compiled, Alt F5. See, strings are unequal and the value returned by strcmp is what? Minus 1. Is that clear?
Yes.
Yeah, I'll show you one more thing. I'll make this again G. So first characters, first it will compare the first characters. What it is? G and G. Okay, so if I assume the ASCII value of G is 66 and this G's ASCII value is also 66, 66 minus 66 is 0, and then it will go for comparing the second characters. Okay, so F minus F again, So since both the letters are same, sorry, first it will take white space. This is also white space and this is also white space. It will compare them and will again 0. Next it will go for comparing the next thing, again 0. Next again it will go for comparing the next thing, 0. Next again 0. Now what finally it returns is 0. Now in case if the first character is the same, say this is, let me make this as E and F. Okay, E F. Now what is happening? They are not same. The strings are unequal, and what the strcmp should return, say this is same. Now this is E and F. Okay, so you're trying to subtract from the ASCII value of E the ASCII value of F, and ASCII value of F will be definitely 1 bigger than what the ASCII value of E, because F comes after E. Okay, now again it should give you the negative value. Negative value. I'll save this. Compiled. Alt F5. See now strings are unequal and the value returned is what? -1. Again minus, negative value. Why? Because E and F it is comparing, so it will try to subtract the ASCII value of F from ASCII value of E. Now you'll get the difference as -1. Okay, now let me make this as, instead of F, E, F, G let me do. Okay, now what is the difference? -2 is the difference. Okay, I'll save, Alt F, save, Control F9. Now you should get it as -2. See, -2. Strings are unequal and the value that is returned is -2. OP people understood?
Yes, sir.
Yeah. So if strings are exactly same, what strcmp returns is 0. If the first string is lesser than the second string, the ASCII values of the first string is lesser than the second string, then you get a negative value. If the ASCII values of the first string is bigger than the second string, you get the positive value. Okay, so that is greater than 0. So if the ASCII value of the first string is lesser than the second string, you get the negative values. How you're getting, you understood it. So we'll go to the next program.
So what about capital letters?
Yeah, capital letters. Yeah, so ASCII value of capital letters is lesser than the ASCII value of what? The lowercase letters. Now yesterday when I was explaining, I told you ASCII value of A, uppercase A is 65. This is true. Okay, and ASCII value of lowercase a is how much? 97. And ASCII value of 0, I told you to remember these things. 0 is 48. Okay, say you are comparing uppercase A and lowercase a, you will get it as negative value. Let me remove all these things. Let us compare only two things, uppercase A and lowercase a, so you'll understand it more clearly. I'll remove this all. I'll put here lowercase a, and here I'll put it as uppercase a. I'm comparing uppercase a with lowercase a. Okay, now if you want to ignore the case, there is one more. I think stricmp, correct? No, that is what you have to use. Okay, so ignoring the case. So now this will not ignore the case, it will even consider the case also. ASCII value of this is 65 and ASCII value of this is 97. Now if I compare, it should say strings are unequal and the negative value. So how much it should be? 97 minus 65, so it is 52. You have to get minus 52. You have to get. So if I'm correct, the ASCII value of uppercase a is 65. So we'll let me save. Control F9, Alt F5. 1 second. So it's saving the desktop file. It's still saying it is hanged. So just a minute, my laptop is hanged. It's saying saving desktop file. Still. So once again I'll open it again, I'll close and open. Program number 8. Okay, it is saved. So all of you can see my screen?
Yes, sir.
Okay, so it is saved now. So now I've given this is uppercase A and this is lowercase a. So if the ASCII value of A is 65, 65 minus 97, you have to get it as minus 52. Okay, I'll compile, I'll run it. Okay, Alt F5. Okay, now minus 32 I'm getting. So strings are unequal and minus 32 I'm getting. Now how much it should be? Yeah, 32 only, it's correct. 97 minus 65 is 32, minus 32. Hope people understood?
Yes, sir.
Yeah, okay. So now if I interchange, so that means ASCII value of uppercase A is 65, that is correct, and lowercase a is 97, and I'll make this as uppercase A. So now what you're doing, 97 minus 65. So you should get it as plus 32. Alt F5. See, now strings are again unequal and the value returned by strcmp is 32. Now I hope you understood how strcmp works. Okay, and what is the return value is actually from the strcmp. Okay, so now we'll go to the next program. So if you have any doubts, you can ask me. So ninth program. Okay. Now ninth program is to demonstrate the use of strcpy, string copy. Okay. This is a simple program again. So because built-in function, I have taken this str1 character array as just my name, Dr. Harish Kumar BT, and str2 as Bangalore Institute of Technology, and I have two more arrays created here character array. One is str3, another one is str4, and I have one more str5 also, and it is bit. Okay. Now what I'm doing, just observe here. So I'm just trying to copy str1 to str2. Okay. So this copy str1 to str2, and for string 3 I'm copying this. Now what is str1? This is Dr. Harish Kumar BT. I'm copying it to str2. Okay, and then for string 3 what I'm copying, copy successful. So for this I'm just copying this message, copy successful. And next string 4 what I'm copying is string 5, this bit I am copying. So now finally I'm printing. So str1 what it should print, so this Dr. Harish Kumar BT, and str2 what it should print. So since I copied str2 also same, correct, no? Dr. Rajesh Kumar BT, and str3 it says copy successful, and str4 will print bit. Okay, so that is what it should print you. Control F9 I'll do, Alt F5. See, str1 is also Dr. Rajesh Kumar BT, and str2 is also Dr. Rajesh Kumar BT, and copy successful, and it is saying BIT. OP people understood? Hello?
Yes, sir.
G. So str1 I have initialized this initially, Dr. Rajesh Kumar BT. So if you want, you can print it even before doing all these changes. Okay. Now before copying, let me print here. Print F before copying str1 to str2, str2 is equal to %s, let me put /n, comma, then I write str2. Okay, next. Now again one more printf I'll write. Printf after copying str1 to str2, str2 is equal to %s /n, comma, str2, and then copy successful I'm doing, and this is I'm copying in str5, correct, no? That is bit to str4. I'm finally printing them. Okay. Okay, I'll save and compile this now. And now run. Alt F5. You can observe now. See, just look from here. Before copying string 1 to string 2, str2 is Bangalore Institute of Technology. After copying string 1 to string 2, str2 is Dr. Rajesh Kumar BT. That means Bangalore Institute of Technology is overwritten by name Dr. Rajesh Kumar BT. And then I'm printing str1, str2, copy successful, and then BIT. Just to understand how Strcpy works. Okay, I hope you people understood with this. Okay, so this is the 9th program. So now we'll quickly see the 10th program. So any doubts in this 9th program? So remember, in strcpy, this is destination always. The first argument is destination and the second argument is source. From here you'll be copying to this. Done?
Yes.
Yeah. And similarly strncpy is also there. When you are using strncpy, it takes 3 arguments. Say for example, if I change this to strncpy, so destination string, source string, and one more argument, comma, say 5. Now what it will do, from this source string it will copy only 5 bytes to str2. Okay, so this is strncpy. So but strcpy, what it will do, it will take only 2 arguments and it will copy the entire source string to destination string. Okay, people understood? So now if I write something like this, now from str1 it will only copy first 5 bytes. So d1, 2, a dot and a space and a h. So till here it will copy. Okay, dr dot space and h, only first 5 bytes will be copied from str1 to str2. Okay, people understood?
Yes.
Yeah. Now I'll remove this. I'll just make it as strcpy. Okay. So if you want, you can change those things and you can execute. Okay. So now we'll go to the 10th program. Okay, so now, in the first example we understood concatenation. This is a demonstration on how to use strncat. So same as strncpy which I showed you. That used to copy the so many bytes from source string to destination string, but this will go for appending so many bytes from source string to destination string. So I have my source string as this EFGHIJKL and my destination string as ABCD. Now what I am doing, now I want to append ABCD is already there. From my source string I want to append 5 bytes to ABCD. So 5 bytes means 1, 2, 3, 4, 5 till I. Okay, so these many bytes from my source string I need to append it to my destination string ABCD. Now what I do, strncat, destination I am specifying and source I am specifying. From this source how many bytes I want to append to the destination, 5 bytes. So EFGHI, correct, or till I. So it gets appended to destination. I am printing the source string also and the destination string also. Now the new destination string that gets printed after strncat is ABCDEFGHI. Okay, and JKL will be excluded. So I'll save this. I'm running. Alt F5. So you can just observe now. Source string is EFGHIJKL and now the destination string initially before concatenating the destination string was only ABCD. Now after concatenation the destination string is ABCDEFGHI. So 5 characters from the source string is appended to the destination string. Okay, so this is what string and cat. So these are the examples. Okay, now we'll go to the PPT and we'll just continue with the introduction to data structures. Sir? Yeah.
Sir, instead of strn concat, we can use strncpy, sir.
Yeah, once again.
Specify the 5 bits.
Yeah, the strncpy, what it will do is it will override the destination string. So now strncat, so destination string you already have ABCD. Just observe what I am writing here. ABCD. To this ABCD you'll have EFGHI appended. Getting? So if you change this to strncpy, what will happen? This ABCD will be losing it permanently.
Okay.
Yeah, so what happens, only the first 5 characters of your source string EFGHI gets copied to the destination, and what destination will become is only EFGHI. Okay, I can show you this. So we can do this. Now strn, instead of this cat, I'll put it as cpy. Okay, I'll save this. Now in the destination it will print only EFGHI. Okay, I'm saving it. I'll compile. I'll run it. Alt F5. Now see, now source string is EFGHIJKL and the destination string is only EFGHI, and ABCD, what happened to ABCD? Overwritten. Understood? That is what is copied. Copied 5 bytes, no doubt, to destination, but the original content which was there in the destination string, that ABCD, is lost forever. So if your intention is to append to the end of that, then you have to use strncat itself. Now this is strncat. Correct now?
Yes, sir.
Okay, now we'll go to the PPT. So if my screen is visible, slides are visible.
Yes,
okay. So introduction to data structures. Now definition. So we'll try to understand what is data structures, and before understanding the complete data structure, first we'll try to understand what is data. So data is nothing but the collection of raw facts, or the collection of the truths. That is nothing but the data. Or data is nothing but the collection of information. Okay. Now you understood what is the data is. Okay. Any information is nothing but a data, and that is the fact. Information is nothing but the fact. And what is a data structure? So is the data structure is representation of the logical relationship existing between the individual elements of the data. So using data structures, you can go for establishing the logical relationship, or in other words, you can also define data structure as the format for organizing and storing data in the memory. Okay, it is data structure basically defines the format or the way in which the data is stored inside the memory. Say for example, we write int a. Okay, now a is the name given to some memory location, and that memory location now is reserved for storing only the integer value. Correct? No, that is what is a data structure. Okay, and similarly, if I say character a, so the a is the name given to some memory location, and that memory location is reserved for storing a character. So if I say float a is the name given to some memory location, and that memory location is reserved for storing what? The floating point value, something like this. Okay, so it defines the format for organizing and storing data in the memory. Okay, that is what is basically the data structure. Okay, now so data structure is very important. So the format of storing the data in memory is very much important, because without knowing so what is the format of data that I should store in memory, so it is not possible for you to write any of the program. Okay, so data structure affects the design of both structural and functional aspects of the program. And when I say for a program, so a program is algorithm plus data structure. So a program is not only an algorithm, along with the algorithm you should also know the data structure. You should know the format of storing the data in the memory location. So I just know the steps, how to write the program, but I don't know how to store the data in the memory, the format of storing the data in the memory, then your program becomes incomplete. So your program is algorithm plus data structure. You should know the sequence of steps. Along with that, you should also know the format of the data that needs to be stored in the memory. Okay. And algorithm, it's a step-by-step procedure to solve a particular function. In addition to this step-by-step procedure to solve a particular function or a particular task, you should also know the format of the data, okay, that is stored in the memory. So now data structures, again they are broadly classified into two categories. So one we say primitive data structure and non-primitive data structure. Now what are primitive data structure? The basic data types of any programming language are called as the primitive data structure. Say for example int, character, float, double, these are all primitive data structure. Okay, so because you have stored integer value in the memory by declaring an integer variable int a, you have stored floating point value in the memory by declaring float f, something like this. Now all these things are primitive data structures, and on top of this there are non-primitive data structures also. Okay, now these are the broad categories of the data structures: primitive data structures and non-primitive data structures. Okay, so now here is the complete classification of the data structure. So as I already mentioned, the data structures is classified into two types. One is primitive data structures and non-primitive data structure. Now what all comes under the primitive data structures? Under primitive data structures you have integer, character, float, pointers. Now all these things come under the primitive data structures. Of course you can also write double also. Okay, integer, double, character, float, pointers, whether it may be a character pointer, integer pointer, or a floating point pointer, everything come under the primitive data structure. Because for all, why are they called as primitive data structure? Because for storing all these types of data, in the memory, so there is a data type defined in the programming language. Okay, so for example, I want to store an integer value in the memory, there is a type defined in the programming language, that is integer. Say for example, let us stick on to only the C programming language, and there is an data type available, that is int. And similarly, if I want to store a character in the memory of the computer, then I have the data type directly available in the computer, that is char, and then float, and then pointers, and then double also. Now when I come to non-primitive data structures, it is the collection of these things, primitive data types. So we have two things again, arrays and list. So array is a non-primitive data structure, because using arrays you will go for storing the group of related data items. So group of related homogeneous data items. It is not just one item, it is the collection of many items. Hence we say it is a non-primitive data structure. And again in arrays, we have already understood single dimension arrays, two dimension arrays, and multi-dimension arrays. The other non-primitive data structure what we have is lists. And again in this list, it is divided into two, linear data structures and non-linear data structure. Okay, linear non-primitive data structure and non-linear non-primitive non-linear data structure. So in linear we have these many again, stacks, queues, and linked list. Because why they are called as linear data structure, because in stack, queues, and list the data is represented sequentially one after the other in the form of linear. And non-linear data structure we have trees and graphs, because in trees and graphs we don't represent them sequentially one after the other, so it will take a totally different form. So it is represented in the form of a tree, where you have a root node, and the root node having two child nodes, and those two child nodes again having two child nodes. I hope you can imagine how a tree looks like. So hence it's called as a non-linear data structure. So they call non-linear data structure because the data is not represented sequentially one after the other. Instead it is represented non-linearly in the form of either in the form of a tree or in the form of the graphs. Hope you people understood with the complete classification of the data structure. Any doubts here?
No, sir.
Okay. So these are very primitive. So why we are calling them as primitive? Because they are directly available inside the programming language. The data types are available. Okay. So now using those, say for example, I want to declare an array. Array, I am calling it as a non-primitive data structure. What is that I do? I use this primitive data structure and I add on top of it. Say if I want to declare an array, so integer array, int a of, so only int a will do what? So creates an integer variable, that's all. Now if I want to create an integer array, int a, and I am writing this big bracket and closing big bracket, and I define the size, correct? So this non-primitive data structures are built on top of this primitive data structures. Okay, so this is the complete classification of the data structures, and we are going to focus now much on all these things. Primitive data structures you have understood all these days. Okay, so our focus will be on the non-primitive data structures now. So arrays we have discussed in detail already, and you have also done one lab program on it. So now our focus will be completely on this other type of non-primitive data structure, that is list, and will be discussing all these things in detail. Linear data structure and non-linear data structure. Stacks you'll understand the queues. Again in queues, normal queues and circular queues. Lists you'll understand, singly linked list, doubly linked list, and trees you'll understand. So you have completely balanced binary tree, binary search tree, and you understand the graphs. Okay, we'll go to the next slide. So primitive data structures. So as I've already told you, so these there are basic structure and directly operated by the mission instructions. Okay, so sorry, not there, these are. So these are basic structures and directly operated by the machine instruction. That is what I told. Data structure that directly operated upon the machine level instructions are known as the primitive data structures. Example: integer, floating point number, character constant, string constant, pointers, etc. All these things come under the primitive data structures, or you can say the primitive data types also, because they define the format of storing the data in the computer memory. Okay, so now primitive data structure, most commonly used operation on data structures are broadly classified into the following types. One is create, selection, updating, destroy, or delete. So you can go for creating, say using the primitive data structures, int, float, character, what you want to store. You can go for creating. So you can create a new data inside the memory. After creating, you can go for selecting it. Say I have already defined an integer value, I have already stored an integer value in the memory, and you can go for selecting it. Okay, and so you can also go for updating it, and you can also go for destroying or deleting it. So these are all the operations which you can do on the data which is stored in the memory location using the primitive data structure. You can create the new, you can go for selecting the one which is already stored in the memory, you can even you can go for updating it, and even you can go for destroying or deleting it. So non-primitive data structures, there are more sophisticated data structures, so they are called as non-primitive data structures. Okay, so non-primitive data structure emphasize on structuring of group of homogeneous or heterogeneous data items. Okay, so when I say primitive, it focuses on only one element, okay, either an integer element or a character element or a floating point element or a double element, or it could be a pointer of type character, float, or integer. But when I say non-primitive data structure, it emphasizes the storing of group of homogeneous or heterogeneous data items. When I say non-primitive data structure, their focus is only on storing not just one element, so focusing on storing a group of heterogeneous or homogeneous data elements. Okay, so when I say homogeneous data element, a group of elements of the same type. When I say heterogeneous data element, group of elements of different data types. Okay. Okay. Now again, this non-primitive data structures broadly classified into two types: linear data structures and non-linear data structure. Okay. Now what about linear data structure? Linear data structures are a kind of data structure that has homogeneous elements. So that is the reason we discussed. I'll go back to the classification again. Yeah. So linear data structures, so stacks, queues, and list, so they have homogeneous collection of elements. Okay, sorry, this one. And data structure in which elements are in a sequence and form a linear series, so they are sequentially arranged. And linear data structures are very easy to implement since the memory of the computer is also organized in a linear fashion. So compared to the non-linear data structure, implementing the linear data structure is quite easy because even the memory, computer memory, is also organized in a linear fashion. So what is the meaning of linear fashion? So say that the memory location, what comes after memory location 1000, 1001? What comes after memory location? Which memory location comes after 1001? 1002. What memory location comes after 1002, 1003? Even the memory is also organized in a linear fashion, and if the elements are also stored linearly one after the other, so the storing is very easy. Okay, so because memory is also organized in a linear fashion, and what kind of implementation we are writing to store in linear data structure? Sequentially, one after the other. Okay. So some commonly used linear data structures are stacks, queues, and linked list. So these are the examples for the linear data structures: stacks, queues, and singly linked list, or linked list in general. You have in linked list singly linked lists also, and doubly linked lists also. Later you'll understand all of them. So non-linear data structures is a data structure in which data item is connected to several other data items. So say for example, I was mentioning trees. So in trees, so just I want to write. Just a minute. Okay, 1 second. A nonlinear data structure is connected to many things, but whereas linear data structure is connected to only adjacent things. I'll show you. One second, it is loading. Whiteboard is getting loaded. Just a minute. I don't know why it's taking so much of time. Or else I'll open this. It's taking more time. So just a second. Okay. So nonlinear data structure is something like this. This is one data, and so trees are the best example. So this data is connected to two things. Okay. So this is one data, and this is another data. This is one more. So this particular data is connected to two things now, and this again can have two more nodes. Something like this. Okay. So this is I can have the nodes connected here again. Okay. This. And when I say linear, it is something like this. So this is one node, this is another node, this is one more node. They're linearly connected. Something like this. Okay, it goes like this. This is what linear. Okay, so it is stored sequentially one after the other, but this is not sequential. So this storage is not sequential. Okay. So nonlinear data structure is a data structure in which the data items are connected to several other data items. So they have something like parent-child relationship. So nonlinear data structure may exhibit either an hierarchical relationship or parent-child relationship. That is what I mentioned. Hierarchical relationship or the parent-child relationship. Both are same. So this is what the parent-child relationship. This is the root node, or I can say the parent of these two child nodes. Okay, and when I take this node, this is the parent of this node, and this is the grandparent of this particular node. So they have something like the family tree. Okay, the parent-child relationship. So data elements are not arranged in sequential structure, and the best example for nonlinear data structures are trees and graphs. Now what I have written here is a tree. Similarly, you can also have a graph. Okay, so graph also. So we'll understand later when we go there. Okay. Okay. So some work is happening at my home. That's why the disturbance. Sorry for that. Okay. Okay, and non-primitive data structure, what are the operations you can do? So again, in the primitive data structures, linear uh, data structure, what are the operations you can create, and you can go for selecting, you can go for updating, and even you can go for destroying. And what are the operations you can do on the non-primitive data structures? So you can go for doing this traversal. Yes, sequential data structures you can traverse. If it is a tree also you can traverse, and you can go for inserting. So while you are traversing, let's see, linear data structure, okay, non-primitive linear data structure, when you're traversing, say I want to insert a new node here, so one more new node between these two, you can go for inserting, okay. And then the same thing can also be done in the trees also. See, I want to insert a new node here, you can go for inserting. A new node here, you can go for inserting, okay. So traversal, insertion, and even you can go for selecting, even you can go for searching, you can go for sorting, merging, delete, or destroy. So all these operations can be done on the non-primitive data structure. And when we take up each of the non-primitive data structure, and when we are discussing them, so we are going to discuss all these operations. We discuss how to perform all these operations on any of the non-primitive data structure. Hope you people are understanding.
Yes, sir.
Yeah, we have done already these operations on the array, okay. So you know how to traverse an array, how to insert into an array, how to select an element from the array, how to search from the array, how to sort an array, how to merge two arrays, how to delete an array. All these things you know. Now, but the same thing we apply on a non-primitive data structure now, okay. Yeah, difference between them. So a primitive data structure is generally a basic structure that is usually built into the language, such as integer and float. That is the basic thing. Whereas a non-primitive data structure is built out of primitive data structures. That is what I told. All non-primitive, it may be an array, or it may be a stack, it may be a queue, it may be a linked list, or it may be a tree, or it may be a graph. All these things are built using the primitive data structure, okay. So in a meaningful way, such as a linked list, binary search tree, there is one more tree also, AVL tree, we'll understand later, and graph. So that is, so all non-primitive data structures are built out of a primitive data structure, so in a more complex way. OP people understood till here. And from this onward, so this topic, so description on array, because arrays also I told is a data structure, and we have already understood the arrays in more detail. I am not going to touch this part again. One dimensional array, and the basic concepts on the arrays, and how arrays, linear arrays, are represented inside the memory. So all these things you know, how to read an array, how to print an array, what is the lower bound of the array, upper bound of the array, everything you know. I'm not going to touch this part, okay. Okay, so this sense we have already discussed in detail. So my intention was to tell you about the primitive data structures and non-primitive data structures. Now next what we are going to understand is the stacks, the first data structure, the first non-primitive linear data structure. Oh, people understood till here? If you have any doubts, you can ask me. So next what we understand is this, chapter 3, stacks and queues, okay. So this is from here we are going to discuss how what is a stack, how the stack works, what are the operations you can perform on the stacks, what are the applications of the stacks, all these things, okay. So now today I want to stop here. From tomorrow I will continue with the stacks, chapter 3, stacks and queues. So if you have any doubts, you can clarify now with respect to the linear data structure and non-linear data structure, primitive data structure, non-primitive data structure. So and this diagram is very important. If you remember this diagram, so you can easily remember everything. This is important. So I'm not touching this part right now because we have already done it. So our focus will be completely on this part right now. and this you have already studied in the previous semester itself. We have understood this complete thing. So now the first module was completely based on the arrays, correct? No, and the strings. So we are done with this. So now the rest of the syllabus, correct? No, the module 2, 3, 4, 5 is completely based on this, okay, part, this part of the this diagram. Yeah, over to you now. If you have anything to ask with respect to this, the classification of the data structure, what I told you now, you can ask me. So 28, okay, it is downloaded. Okay, so if you don't have anything to ask, okay, it is lunch time, so I will end the meeting, have lunch, and join me again tomorrow. And from tomorrow it is very interesting, all new things which you're going to learn, stacks. Okay, so don't miss the classes, attend it. Okay, thank you.
Thank you, sir.
Yeah, thank you.